Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. My name is Ahmad Fauzan Aziman bin Ahmad ZAIHURI, and today I will be talking about an overview of lightweight concrete, a specialized material that plays a crucial role in modern construction. So what exactly is lightweight concrete? As the name suggests, it is a specialized concrete that made differently than traditional mixes. Instead of dense stone and sand, it utilizes lightweight coarse aggregates and sometimes lightweight fine aggregates. Why do we do this? The primary goal is to reduce the dead weight of a structure. If you look at the data points here, you will see that lightweight concrete typically has an in-place density ranging from 90 to 115 pounds per cubic foot. To put that in perspective, normal weight concrete is significantly heavier, usually sitting around 140 pounds per cubic foot. This reduction in weight is incredibly beneficial for large structures like the bridges and tall buildings depicted in the background images here. Now, let's dig deeper into the specific types. First, we have structural lightweight concrete. There is a common misconception that lightweight means weak, but that is not the case here. For structural applications, this concrete must meet rigorous standards, achieving a compressive strength greater than 2500 psi. How do we achieve both lightness and strength? It comes down to the aggregates. On the left side of the slide, you can see examples of the materials used: expanded shale, expanded clay, or expanded slate. These materials are fired in a rotary kiln, a process that creates a durable yet porous internal structure. Another common aggregate used for structural purposes is air-cooled blast furnace slag. Next, we have a non-structural lightweight concrete. This type is distinct from structural concrete in a few ways. It generally has an even lower density and is made using different aggregate materials. Crucially, its mix design incorporates much higher air voids within the cement paste, which contributes to its lightness and often provides insulation benefits. A prime example of non-structural lightweight concrete, which you can see detailed in this large porous cross-section image on the left, is cellular concrete. We have discussed what it is. Now, let's look at how it is classified. The first major way to classify lightweight concrete is based on its intended use. As listed here, there are three main classifications, all governed by ASTM standards. The first one is structural lightweight concrete. The second is lightweight concrete for masonry units, like the blocks shown in the picture on the right. And the third is insulating lightweight concrete. It is important to remember that the classification of structural lightweight concrete is strictly based on meeting minimum strength requirements in accordance with these ASTM standards. Finally, besides classifying by use, We can classify lightweight concrete based on its method of production. This slide highlights three distinct production methods with corresponding visual examples of their textures above. First on the left, we have lightweight aggregate concrete. This is what we discussed earlier. It utilizes porous lightweight aggregates with low specific gravity, typically lower than 2.6. In the center, we have aerated concrete. This method doesn't just rely on the aggregate for lightness. Instead, it incorporates large voids directly into the concrete or mortar mass. This is achieved through methods like aeration with stabilized foam or air entertainment. And finally, on the right is no fines aggregate. As the name implies, this mix opts to omit fine aggregates entirely from the mix by using generally normal weight coarse aggregate without sand to fill the gaps. It results in a large number of interstitial voids, creating a lighter, permeable structure. To summarize, lightweight concrete is a versatile category of materials, whether defined by its structural capability or the clever methods used to produce it. It offers essential solutions for managing weight in construction. Next, I will pass this presentation to our IMAN.
I will explain the type of lightweight concrete, focusing on lightweight aggregate concrete. This type became popular in the early 1950s in the UK, especially for load-bearing cavity walls. The development of artificial lightweight aggregate allowed this concrete to be used safely in structural and reinforced construction. One example is pumice. It is natural material and is commonly used for reinforced roof slab, especially in industrial building in Germany. Another type is foam slag, which was the first lightweight aggregate used for reinforced concrete in the UK. Finally, expanded clay and shells can achieve high strength, making them suitable for pre-stressed concrete. Overall, lightweight concrete reduces structural weight while still providing good strength and performance. Next, I will explain two more types of lightweight concrete: aerated concrete and no-fine concrete. First is aerated concrete. Aerated concrete is characterized by very low density, low thermal conductivity, and low strength. Because of its lightweight, it can be cut, screwed, and nailed easily, similar to timber. It is usually high-pressure steam cured, which improves its quality. Aerated concrete is mostly supplied as precast unit and is commonly used for floor, walls, and roof. Next is no-fine concrete. No-fine concrete is made using cement and coarse aggregate only. With a fine aggregate, this creates uniform voids through the concrete, making it lightweight and permeable. It is mainly used for load-bearing walls, internal wall casting, non-load-bearing walls, and under-floor filling. In summary, aerated concrete is best for lightweight precast element, while no-fine concrete is suitable for walls and filling application. For the last one, I'm going to explain classification of lightweight concrete. When we talk about this material, we are not just looking at the weight, we are looking at the crucial relationship between density and strength. Generally, we can categorize lightweight concrete into three distinct types. First, we have low density concrete. Think of this primarily as an insulator because it has very low unit weight. It offers exceptionally high heat insulation values. However, the trade-off here is strength. It has a relatively low compressive strength, making it ideal for non-structural insulation purpose rather than load-bearing walls. Moving up the scale, we find moderate density concrete. As the name suggests, This is our middle ground. It has position right between low density and structural grade, offering a functional balance. You get better strength than the insulation grade, while still maintaining some of helpful thermal properties. Finally, we have structural concrete. This is the heavy hitter of the group. It has utilized specific aggregate to achieve high structural efficiency. To be classified here, the concrete typically need to reach a compressive strength.
Uses and advantages of lightweight concrete. Lightweight concrete is widely used in construction for applications such as skirts, walls, insulation, and structural elements. One of its main advantages is the reduction in dead load, which helps decrease the overall weight of a structure. It also allows for faster construction, lower transportation costs, and provides better thermal insulation. These benefits contribute to improved energy efficiency in buildings. Next, durability of lightweight concrete. Durability refers to the ability of a material to withstand the effects of its surrounding environment over time. Lightweight concrete may face durability challenges such as chemical attack, physical stress, and mechanical damage. Therefore, appropriate precautions and protective measures are necessary to ensure long-term performance, especially under different environmental conditions. In conclusion, lightweight concrete is a versatile and innovative construction material. It offers many advantages, including reduced structural load, improved sound and thermal insulation, and higher fire resistance. Lightweight concrete is available in various forms, such as lightweight aggregate concrete, aerated concrete, and no-fine concrete, making it suitable for a wide range of construction projects. When the correct type, mix design, and construction methods are selected, lightweight concrete can produce efficient, durable, and long-lasting structures.